And good morning. Happy Friday. Got a little electro swing going. All right. I think it's time to create an RPC endpoint for sending data to Data Archive. What happens in the VFS when data mutates? It has to go somewhere. Where's dark mode? Trying to make sure I have dark mode on before blinding everybody. Or at least minimizing it. Whoa. I forgot. I was looking at SQLite talks. Well, there. So when data is coming from data plane to data archive, we need an endpoint. We've been working on the endpoints required to synchronize a service with the data in data archive. But now we need something to receive data. I think it would be useful for our test code. Because replicate needs some way of creating a stream of data that we can iterate over and validate. At least part of that API, something that API can be built upon. Hmm. I'm glad it's Friday. So we have this replicate server. It's passed into our gRPC endpoint here. Our replicate server has two things: access to the TiKV data store and to Iggy, our stream service. Now, here we implement everything that's needed for our gRPC endpoint. Right now, if we look at our test code, our test code has one of these available to it. So we could call some function to push data into our streaming service. And in our test code, we're using Piggy. That's our little simple version of our Iggy backend. So server has an instance of that, and it would be nice to be able to use like the full-on API for that, but I don't know, I'm a little conflicted. Do we build out the full API, or do we test using what we have and build up our test using Piggy? I'm leaning towards Piggy. I think that will be simpler. And we'll have a little bit more control over it. So here, what I had from last night's musings, testing stream database updates. This is the happy path, not looking at any of the edge cases, the error cases. We mutate the database. We can fetch the database. Now, where does the mutate happen? Here. Or how far this actually works at the moment. Let's comment some of this out just to make sure we're doing the right thing. This is basically a clone of this test here, where I mutate the database, we get the checksum, ensure that the checksum we got back from the service actually differs from what we have now. We should probably check to see that it's maybe the same. Oh, no, no, no. That's just checking the checksum. Request fetch DB. See, I feel like there's steps that we're missing here. And maybe I'm conflating this with the Reverb client. I still haven't fully booted. Dog was outside this morning. All right. We'll do some TDD and see where it falls over. Okay. And this is that. Cargo test. With a no capture on that. Good. Request fetch database. Now, This is just entirely wrong. See, in this case, we're actually sending the pages, aren't we? Request fetch database. Oh, no. We're asking for that. Yes. Request info. Do we go past fetch database anywhere? I don't think we do. Okay, so we had some of the happy paths up here. Fetch database request happy path. It checks that everything is pleasant. The one that we copied, though. See, I basically want this, and then to mutate it, put the mutations into a stream. Okay, maybe start here. Then we mutate it after that. That goes away. Then we mutate. We need to put the mutations into the streaming service. I wonder if I could use the other test as a fixture. Probably not, because I need too much. Oh, we do get the test context. Maybe. We'll probably reduce this kind of upper happy path to something, some test fixture. Okay. So we mutate the database. Oh, and I got rid of our starting checksum. So we get the checksum. We need to make a request for the start checksum. Interesting. Request fetch database. We don't want that. We want stream database updates. Oh, that's on test context. We do not yet have a wrapper around it. Let's make one. And what was it? Stream database updates? Yep, stream database updates. And that does shard name and start db checksum. Okay. It's not an option. Okay. The response is a streaming what? Database page. Okay. Our little wrapper is done. Let's go back to our test. Stream database updates. Expected 2 arguments. Really? Self, database name. Oh, and yes. It's a tart checksum. So stream response. Good. Must be tired today. I had that on mute forever. Okay. So we're adding this mutate DB and stream changes so that we can see what has changed between two instances of the DB. We will copy the DB to a file similar to this. Let's make a little backup function of async function backup database self DB name. Did return that. What is this? This is just a path buff. Okay. There we go. We do not need this to be async. Okay. Now we could make it async, but I don't think it matters if we block the runtime for this. It bothers me though. So let's try Tokyo. There. Okay. Back here, we have our DB path, backup DB path. Good. So now we diff those. I thought I had something like this already. I think it's in the other context though for data plane. Here. This is for diffing two different databases. Changed server pages. So in this case, we return it a set of database page objects. DB, let's see. I thought I opened both of them. Okay, that's just getting the checksums here. Server file contents. Yeah, this one is slightly different. This one we're not actually doing a diff of the file contents. We're checking the page checksums. Interesting. I wonder, will we need to keep our checksums up to date as well? MutateDB should be doing that. Wrong file. Let's see here. Refresh database checksum, yes. Okay. As long as that's fine. Okay. Let's just open both files. Look at 4K page sizes because we're using defaults here for SQLite. Read. I'm going to read that into something. This is our DB path. Wait, boom. Okay. What do we call this? This is DB bytes. Let DB backup or backup bytes. Okay. Now we want 4K chunks. And this should be a vector. Yep, vector view weights. So DB bytes. Then we'll chunk that. Oh, come on, keyboard. DB bytes dot chunks. Is this 232 dot pow of 12? Well, the same thing. Oh, it's U size. Got it. Good. All right, now we have chunks of each one. So at this point, we want to iterate over them together. So we will zip them and then we will enumerate that so we know which page we're looking at. Sogglebit. How have you been, mate? And welcome, everybody. I'm doing well. A little off my game this morning, to be honest, or open. Right? Um, well, yeah, been hacking away at this. Yep, classic chill radio this time. All right, raid and run, bud. Thank you for the raid. Appreciate it. And welcome, everybody. Um, yeah, hit me with some questions. I'll try to explain what we're doing. So, Paprika, this theme is called Challenger Deep. Let's hear. I really, really like the theme. I like the colors, so I've stuck with it for a very long time. Yeah, you're welcome. Now, watch your eyes for just a moment. We're going to pop over to my architecture diagram, which is in a tool called MonoDraw, which doesn't really have a dark mode. Well, the chrome is dark, but not the contents. Okay, so we are in the middle of this, I don't know what to call it. I've been calling it a new stack, but it's, is it, it could be called a new stack. But essentially, think of a system like fly.io, right? You have a proxy where traffic comes in, it hits something. That then gets shuffled off into where the traffic needs to go. In my case, because we're doing database replication using SQLite, right? We're building the replication engine. Our proxy that we use is specialized and knows where the writers are and where the readers are. Okay, and it knows the state of them. So it will send mutation traffic to the writer and then read traffic to the horde of readers. So you could imagine, maybe you have a forum or something where 1 out of every 10 requests to the site is a mutation. Right? This should be able to scale that just fine. The request would come into the application, your forum software. It would make a change to the SQLite database, but our VFS plugin to SQLite, a virtual file system plugin, would monitor the change, send it to data plane on the same machine, where data plane would shuffle that data off to data archive, which is where I'm currently working today. Data archive would send the data into Iggy, which is, let's say, most people know what Kafka is, a Kafka alternative written in Rust. We would also send it to TiKV, okay, which is a key value store. It's the distributed key value store that's used in TIDB, which also happens to be written in Rust. Probably noticing a theme now. And so Data Archive would be able to respond to requests from the readers, right? A new reader comes online because traffic is increasing, right? The sun is coming over, let's say, pick a continent, North America. People are coming up on the East Coast, they're waking up, and they hop into the forum and start to see, hey, what's new, right? You get read requests happening, new machines come online. They say, tell me, which databases do I need to know about? They ask Data Archive about that, stream the data, so download it, and then just start streaming the changes and keeping their database up to date. Our VFS plugin keeps the readers from writing to the database. It can actually block them, right? Give a IO error if they do try to mutate it. And in other cases, everything works, right? Mutations go to the write machines and read requests go to the readers. Nightshade, dude. How you doing? Happy Friday. So yeah, and welcome. I know many of you. I love watching Togglebit's streams, and we have a different vibe. So hope you all will hang out, and we're just gonna chill and write some code. At the moment, the test that we are trying to write is in. Let's see, it's in replicate. So what we want to do is test this streaming functionality, right? So imagine a reader machine has just come online. It has downloaded all of the databases that it needs to know about, but now it needs to keep them all up to date. So it starts to subscribe to all of the changes. And so we are testing that functionality here. Ah, nice you did. You had to shovel a bit more of your driveway. Didn't finish yesterday. Ooh, I heard y'all got a lot of snow. 16 Fahrenheit feels like 10. Do not recommend. Yeah, well, where I am, that's, yeah. Every year we have a week, at least a week of just single digit temps. So I hear you. Although when you get down to like 5 and the wind's not moving, it can be really pleasant out. And I love the way that the snow glistens in really, really cold temperatures, like 5 degrees. I know that's not like negative 20 like some other places get, or worse. But there's a certain kind of sparkle and sheen on the snow. Oh, yeah. So you're getting a lot of wind. So wind with cold just sucks. That just tears the heat out of you. So in this test, we start with 3 databases. We are only using one database, the happy DB. We ask the server for its check. Well, we calculate its checksum. We make a fetch to get the data from that database. See, did I need to? I feel like this is actually wrong, but we'll come back to that. The test will break. And then we come down to the point where we have synced the database and we need to start listening to the streams. So at this point, we ask for database update events. Tell us whenever data archive is told about a change. Now, after that, we mutate the database and stream the changes. That's what we're working on at the moment. We want those changes to get passed through the system just so that we can exercise the server code for um, storing the data into TiKV and into Iggy. Um, let's look at that code. So we back up the database so we can tell the difference between the mutations, like which pages of the database file changed. Right? Is it page 1? That's bytes 0 to 495 or 96? 0 based, 1 based, whatever. Okay. This is what we will use to sending the response. For sending the response. And at the moment, we're going to diff 2 files in 4K chunks. Let's see. Here to the no, 12 is 4096. Good. So let's chain these two things together. All right, we have chunks. Actually, we'll zip them. Can we zip? Oh, maybe chunks. We will enumerate that. At this point, we can iterate over these. So that's our zero-based page number. Oh, is it a result? It's just chunks. Chunks. Enumerate, zip chunks, chunks. Okay. Let's call it page data. Naming things is so hard. Backup page data is equal to db streams dot. Oh, that's a tuple. Got it. Good. So if they are different, then we will send data into this stream. Let's set up the stream first. Stream tx dot send. It wants a received message. That's an IGI type. We should probably extract these two variables though. Okay. Partition ID in this case is always 1. Current offset. Do we need to keep an offset? This is the position in the IGI log. So it gives you a point that you can move back to. Oh, and thank you for the follows. Relatev. Don Silas. And any JSON. Thank you. Now, inside of the IGI log, let's have a mutable value that we just increment for each page that's different. After we send, current offset increments. And the message. This is a polled message. It's interesting that current offset and offset in this case, I think, are always going to be the same. State, that's fixed. What is that message state? Yeah. Always available. Timestamp. This should be some sort of epoch. Getting the epoch in Rust is kind of a mess. Oh, well, what is this? Super bright. Here it is. It's basically this. Oh, that's a result. We'll just. Okay. ID. This one's a little tricky. We're going to come back to that. Checksum. This is the checksum of our payload. Technically, we don't use that. We don't use it in Iggy. We actually use it as the as a header value. So our payload, that's an easy one. Let's move that up. It's just bytes. Can we say from page data? I don't have bytes imported. I wonder, can I just give it that with a into? Yes, okay. Checksum, headers, and length. Length is, what size do they want? They want, oh, Iggy byte size. What? I've never used that before. What is an Iggy byte size? This struct uses byte from byte unit create. Interesting that you can give it values like that. So we can just, oh, it looks like we could just into this type. Let's try that. So 2 u32 to pow of 12 dot into. U32 is not use size. Oh, U64. Okay, so we did 32 and use size, but not U64. I don't really care if it's one or the other. It's 4096 either way. All right, so we have headers, we have the ID, we have the checksum. I think we will use this checksum. Since Iggy is not calculating it, we can use it. It's data that we provide. I mean, really, you could put whatever you want in there, huh? Some mystery U32 value that goes in and comes out. Paprika6, thank you for the follow. Expectation Max, thank you for the follow. And Elabor, Elabor Leet, thank you for the follow. Checksum. All right. So we have to provide a checksum, which is fine. We have some little tools to do that. We usually checksum all sorts of stuff here. When we mutate the DB, we actually keep a checksum up to date for every page. So let's get a reference to that checksum DB. That's going to be self dot, oh, keyboard. My keyboard is old. I've got this old Kinesis Advantage Pro with the finger wells in it. And I don't know if it's my keyboard freaking out or my USB hub. It's not quite right. I suspect it's the keyboard, but I'm not sure. Checksum DBs dot get DB. So we give it a path and we get a reference back to it. Okay. Consider borrowing. Sure. Operators can all be, oh, does this not return? What's an option? All right, now we have checksum DB, so we can get our checksum. Or was it, what's the program map? Page checksum. We give it the page number. Oh, but is this 0-based or 1-based? Yeah, so we give it a number. Not seeing this being incremented. I should really comment on this if it's 0 or 1-based. Okay, great. It is 0-based. Let's make a comment. Okay, lost our position. ZBNOB. Okay. Now we know. Returns checksum for a 0-based page number. Done. Now we need headers and ID. So ID for us is going to be a transaction ID. SQLite has transactions in their wall log, which are separate from transactions at the database level. Right? A begin and a commit. In this case, in the wall log, a transaction is a section of the file that is then followed by a certain kind of message. Right? So in SQLite, you can actually have multiple transactions ending up multiple SQL transactions being in one wall log transaction. So let's get this in new. Now we need our epoch, which is our timestamp. Let's bump that up. Now we have the salt and some change value. In this case, a salt value is used in the wall log it's an incremental value, so it increments. And it increments when the wall log is, for lack of a better term, truncated and reused. Right? It's so that SQLite can tell what data is old and what data is new, because it doesn't actually truncate it. It just goes back to the beginning of the file because that's more efficient. The operating system no longer has to allocate you disks on page or pages on disk. It's Friday and my mind is melted from the week. So it will simply reuse it. But when doing so, it changes one of the header values of each record, and that's the salt. So we have our salt value here, which we'll just come up with a value. Smash the keyboard, and I change, let's say it says, oh, all of these in theory would be in the same transaction. Let's bump these outside of the for loop, and we'll just give it some other value. Yeah. Well, it's either that or we make them as separate transactions. In this simulation, I don't think it really matters. Let's have fun. They'll each be their own. Let's use that. An incrementing value. And that's the other thing about these. Each one needs to be an incrementing value. Otherwise, they get stored in the key value store in the incorrect place. TiKV. Dojo Drummer, thank you for the follow. All right. Unreachable expression, yes. Let's go ahead and move that up. All right. Ooh, mismatch types, yes. That needs to be dot as. We could into. Can we provide the type that we want to go into? No. We have to use that syntax, and I don't want to do that. Let's close that file. So we'll dot into and provide the type we want to go into. Mismatch. And our transaction ID is naturally a U128. It has 64 bits of timestamps, 32 of the others. You like the idea of calmly beating your head against the wall as you try to figure out what is going on. Oh, that's great. Yeah. Well, thanks for hanging out. Yeah, this is my really long-term project. Basically, okay, story time, I guess. We have a moment for story time. So I was going to start building on the Fly.io LiteFS system. I had a project already started up. I would like to basically create a WordPress alternative, right? I'm a bit of a back-end engineer and a web developer. I've been doing web development since IE3, right? I don't know what year that is. Web developers, we remember the internet and browser stages and features. Um, and so I wanted to just make a little website builder, right? Uh, my wife, she wants me to build her a website. And so I'm doing that, as you can tell. um, so first, we need database replication. I was going to have it built on SQLite because I'm not just building her a website, I'm building a method of building websites, a la kind of WordPress like, or Square Pages. I don't know. Pick your poison. Oh, IE3 was 96 to 97. Got it. Yeah, that makes sense. um, dog's barking. Well, all right. So I'm building a website. I went to fly.io. I thought this would be a great place to build this. I saw the LiteFS project and thought that's what I'm going to build it on. But the LiteFS project is using a fuse-based file system, which there are limitations, right? It can only monitor so many changes so quickly. Um, in short, I decided I'll go another route. I want to basically build LiteFS in Rust using a faster mechanism than Fuse. So I went with the VFS route, creating a virtual file system plugin. And then I spent some months actually figuring out how to get a VFS plugin working in SQLite. And then past that, I actually started writing cluster management first because I wanted to organize the cluster. Oh, and this is the nth iteration of the architecture. So it used to be, you would have a proxy that can talk to other apps across the network. And then we also had this thing called Melody, which was a writer. But there was the cluster management piece of this. Where was that? Oh, here it is. Cluster management came in schema, architecture version 2.0. And I spent some months working on that. It was a lot of fun, but I've kind of sidelined it at the moment because I've more or less found other ways to do that, and and it's kind of just iterated piece after piece into what we see now, where we can have basically a set of proxies that simply talk to everything, know the state of everything, can help you read your own writes, and it's just going to be I guess, faster version of LiteFS and the stack that Fly.io has. So I don't know if anybody's ever played with it, but LiteFS is pretty slick. It also lets you download versions of your database from almost any point in time, which I is so easy to do when you have something that the data is going through. Right? I also decided not to fan out from the source machine because I wanted to reduce the amount of processing that the source machine has to do. Right? So I want as much CPU and disk I/O going into this side of the house, basically the app and the database itself, than this side of the house. These should be insanely light, using as little CPU as possible. because there can only be one reader for a given database. Right? Yeah, it's a fun project. It's kind of long term. And Ruby, thank you for the follow. So eventually, yeah, we'll get to some web dev next year. Actually, it might be before next year. We'll have to see because sorry for the flashing. Going back to this, um, this should be no wrong one. That there we go. Yeah. Give me a sec. I have no idea. Okay. Anyhow, let's get back to it. So we have our pulled message, right? We're trying to create this stream of data that's coming from the writer going into our system. Now, we would receive something and then calculate, you know, a transaction ID. I think checksum is going to be already generated. We have checksums from source to destination all the way through from the writer all the way to the readers so that we can verify data integrity at every single point. And not just for each page, but for the combined checksum of the entire database. Because if it ever gets out of sync, we want that machine to just blow up, get out of rotation, sync everything again, right? Recover, and keep going. This one, it's an option to a hash map. Now, in this case, we need a couple of header values because we have to produce a certain kind of message when sending the data to the readers. Well, let's get that. This will be some headers. Headers is equal to message headers. Oh, it's a hash map. That's right. Okay. Now I don't remember what the headers are supposed to be. There's a bunch of header value. Is it in here? Okay. And you can see here that I was actually storing the checksum as a header, but I don't think that's needed anymore. Let's get rid of that while it's still fresh in our minds. And so we'll just have the page number and the database checksum. Right? The page checksum will be that other value. Okay, message. We skip some messages. We get the headers. We get the page number. The checksum header is not the checksum header. Okay, let's get rid of that. Goes away. Yep, that goes away. So either the first one's an error or the last one is an error. Oh, you have a stupid question. Great. In Unix and Linux, everything is a file. In Redux, everything is URL. Is there a difference? In my ideal Windows OS, the configurations are all stored in a registry database. Your ideal OS would not allow exceptions to this. In Michael Stonebreaker's DBOS, the OS is database oriented. Okay. So the question is, why differentiate the file system and system databases? That doesn't sound like a stupid question, so I challenge you on that. It's a very kind of interesting question. So I've never used Redux. I'm familiar with kind of the Windows registry pattern. Had to do a bunch in that before. Um, but I see these two things as subtly different, right? Windows itself uses the registry. The kernel, I don't think, knows about the registry. It knows about files, and the registry might be a file at the kernel level, right? I think the file system is simply a way for humans to rationalize data store, right? The file system is a database, right? What is a database? It's a place where you can stuff data and get it back, hopefully. So in this case, with like SQLite, you could store a SQLite database in another database, right? You could have SQLite databases as a portion of a NoSQL database stored in the cloud that is mapped to a fuse-based file system somewhere. But that's all mumbo jumbo. The idea really is just that we need a way to organize data. And that's it. Right? It's basically a key value store. It has certain kinds of characteristics where the data can grow, it can shrink, and really it has to be mapped to some sort of physical media in the case of a file system. Be it remote, be it local, be it tape, disk, right? SSD. So I guess it's a bit of an interface to the physical media as well. If you look at the old interfaces, which still exist, there's, was it LSeq? Reposition, read write, file offset. What does that make you think? Like, oh, it's some sort of magnetic tape rotating to a specific point so that we can start reading, right? We just like to see more use of the metadata of files and programs and access to that metadata. Hmm. Sounds like witchcraft. Yes. Like I'm sure you've all seen the old big reel-to-reel machines. Was it the um what is it? I don't remember them anymore. No, I want the mainframes. Oh, it's bright. Thank you, Wikipedia. Oh, look at that. It looks that is so cool looking. I like to think that this section right here is the printer, right? Because you have these pages coming out somehow. They got their little dot matrix on this desk though, so maybe not. You can't see the data storage. This is so clean. I don't know that it would be the role of a file system. I think that you have to start with a pointer to data, right? And the pointer needs to be something that a human can reason about. I mean, it could be a phone number. All right, here, let's take it. Oh, there it is. Yes, these guys, and they could switch out the tape drums. They're like huge ones. Is this the Computer History Science Museum? No, the technologist technologisch. No idea. Right. This is file system 1.0, right? Or not that far off from 1.0. We're not going back to like um, woven wire systems. And that looks so cool. You have to imagine that this plexiglass here wasn't there when it was running. Probably just took the panel off so you could see the inside. So many early programmers were also musicians. Yeah. Yep. Well, it was a way to store stuff, right? That was also pretty cool about early tech, right? You used what you could get your hands on. My first disk drive was I could actually store data to an audio cassette. I don't know if anybody remembers those. Okay, we now need that. Good. Okay, so we've removed the extra header. Now we just need these two headers. I'm going to copy this. Headers. It needs to be mutable. Page number. whatever our value is. Now, header key, I think there's a header value we have to import as well. No, it's a series of bytes. But we have to tell it what kind of value it is. That's right. Header value, Iggy, new. Oh, it's just pub. Okay. I think we just want raw for header kind. And then the value. Oh, wait. No, this is U32. And we have to give it. Oh, there's no new. Oh, what is Iggy? Great question. Iggy is a Rust-based streaming platform. Message streaming reimagined. Persistent message streaming platform written in Rust, supporting quick TCP and HTTP protocols, capable of processing millions of messages per second. Um, yeah, this is Iggy. It's like a Kafka alternative. Woven memory, you say? Yes. Let's take a peek real quick. Woven memory. Can you imagine people doing that by hand? Imagine debugging that. Yeah, no museum today. Hmm. A push pop stack framework for Iggy. I call it Iggy Pop. That's funny. What's the value? Value here is, oh, it's bytes. That's right. This is whatever our page number is. ZB page number. We have to increment that by one here because SQLite page numbers are one based, which has led to errors. Two begin bytes not into. Hmm. What about if we have a reference to it instead? Hmm. Wants tonic cogen bytes. Really? I don't know, but it's kind of sleepy, isn't it? song. It's called Classical Mood. Bye bye. All right. So we have the key, we have the value. We're just missing this. Is tonic cogen bytes actual bytes? Bytes. Modules. Struct. We can write to bytes. I don't see any kind of useful traits. Extend from a box of U8s owned from a vector of U8s. So we could convert that into a vector and then go into that. Come on. Come on. Okay. So they want something that's owned. They want a vector. Yeah, I do miss the generic parameter on into. I don't really like typing, you know, a trait name with a generic parameter. I much prefer the function, but I get it. And this song is actually very slow as well. It's a little too chill. Okay, this one's better. Let's do database checksum. It's going to be pretty much the same thing. Hmm. We don't actually know the checksum. Maybe we make multiple mutations. Okay, this one's got me. Have I made a mistake here? Dun dun dun. Because I'm thinking we're going to be sending a page back, but a page change does not, a single page change is not necessarily representative of a DB checksum. A DB checksum happens at the end of a series of page changes. Basically, let's go back to data proto archive here. Is this the USA anthem? The national anthem. It is. Well, no, I can't really fast forward this one, can I? Oh, it's got some fun riffs in it. All right. Okay, I think this has to be rethought because database page, because it's not really a page that you're after. It's more a larger unit. Right? The rest of the system deals with page checksums, right? And asking for the database at a specific checksum. But here, this is wrong. Clearly a book. It is a book, isn't it? I'm done with Christmas music. All right. Database page number. Yeah, this isn't right. We shouldn't be returning a database page here. This is, okay, I'm glad we got to this point, because that's wrong. This should be a collection of these things that have page number, page checksum, page data, but not the DB checksum. That comes later. Database transaction, which might include multiple of those things. At this point, I could say the type would be database page. Is that how we do this? I'm not that familiar with gRPC. Status. Where is status used? Oh, there it is. Same color. Same length as string. I didn't see it. Okay, so we just give the type first. Okay. And now that it's on that, do we need to have page be the first value? That's not what I meant. I'm practicing my multi-vim. Okay, whatever. Database page. That's database page.data, db page.checksum, db page.number. Why don't we just call it page, page.data, page.checksum, page.number? That's better. And this should be a stream of database transactions. Okay. I like it. That's going to break some stuff though. Let's check the workspace. Yeah. That is not the only error. Come on. Hey, Dojo Drummer. So I had been using a project called LightFS, which is a fly.io kind of feature. They have this distributed SQLite. Click on it, it might be bright. Let's see. Of course, it's bright. Um, and there's all sorts of GitHub info on this. Let's see if we can find that real quick. So if you look in here, replication not working. No, that's not what we want. Multiple databases. Here we go. Are multiple databases SQLite files supported per fuse mount, right? Because the way that fuse works is you say, this part of the file system is actually this program over here, right? All right. There's no hard limit. Haven't tested with a high number yet. And this is the creator of it. I think Ben B. Johnson works at LightFS. I had quite a few people ask to run Lightstream with a database per user, making LightFS eventually support a large number of databases a priority. Um, yeah, but you're on top of Fuse. So you're paying a performance penalty already. Right. And page number, DB checksum. How much of a performance penalty is Fuse? It depends on a lot of things. Um, and that's the thing, right? You're already sitting in an abstraction, and then you're adding another abstraction on top. Um, well, okay. I don't know what a performance level penalty would be, like a percentage based one, like how much of your IO is killed by Fuse. Um, we could probably Google that though. Now, the alternatives to Fuse are to use, like SQLite supports having a virtual file system. And my eventual goal is to, let's go back to the architecture because, eventually there will be a v5, is to have this little box here, a little bit more of a container that you can shove WASM bits into, right? And then it has a SQL interface that interacts with VFS and whatnot. Right? So, yeah, my goal really is to run as light as possible because I have to pay for bootstrapping this thing, right? It's not like I can just walk down the street and say, like, hey, buddy, you, give me your wallet. Well, I guess you could do that, but don't do that. Do not do that. Um, and have somebody else pay for this, right? But because, I want to keep it light, I have time. So I'm going to spend my time to make this light, and then I'll be able to scale it and scale it much, much more than you could otherwise because the VFS is super thin. Data plane, incredibly thin, right? And most of the thinness here comes with the reduction of disk I/O. How many times do you have to touch the disk per commit to the database? Right? The wall log does a really good job of basically you're touching it twice. maybe 3 times, right? You write some pages, and that's not really hitting the physical media yet, right? You have to sync for that to happen. So there's a bunch of writes, there's a sync, but there's also an update to some shared memory, which really isn't disk. So maybe once per transaction there. But then if you're doing fuse, right, the way that I believe I saw that they were doing it, they were hitting it multiple times um, in order to write a secondary transaction log. So for every event that comes through here, right, you end up writing to the database, and they support other kinds of journaling modes. I'm being much more opinionated. I only support wall log mode so that I'm not hitting the database twice. Or I'm not hitting the file system twice, is what I meant to say. Because for journaled mode, they would see the transaction coming through in journal mode and then basically create something like a wall log for transactions that are happening. But if you don't have that and you're using the wall log as your transaction log, then this gets very cheap. And if IO on your writer of your database machine is your limiting factor, we'll get twice as much for the same cost. And, twice as much is a lot for the same cost. What is Iggy used for? Iggy is used for streaming the data, right? So that's my Kafka replacement. And data will come in, it will go into the TiKV cluster to where a machine that's bootstrapping would load database pages from, right? A reader coming online would say, hey, data archive, what databases do you have? It would reply, and then TiKV would give all the pages, right? But to stay in sync, that machine, now having all of the databases, needs to know all of the transactions that are coming through. So we would have maybe a day's worth of data stored in Iggy, and that would be able to keep the machines up to date. Good question. All right. Um, so we've got our page numbers, our DB checksum. Let's make sure this is right. This is not right. What is our value here? We need our page checksum, and that is checksum. There we go. So we have our headers, provide our headers, and that's done. Okay, now the challenge I see is that this is now incorrect, right? Because of what we just discovered over here, in that we need to send the full database transaction and not just a database page. There might be, 30 or 50 pages being updated in some massive transaction. Oh, that's cool. So you met Hey, my Joel Dice. I've never heard of spin. Sounds interesting. Well, well. Hmm. Database transaction. I feel like this message, when it gets to, here, we're going back to the architecture diagram, watch your eyes. Um, so this data coming out of data plane would basically be that large transaction as it comes into data archive. We pick that transaction apart, store it into different places, into TiKV, but I think it should just go straight into Iggy. Very little processing. That's cool, Doja. I don't think I've ever really looked at their website. Incredible serverless. Hmm. Build your app. Yeah, see, most of the problem people have with WASM is that they're building in something that doesn't compile to WASM. Um, oh, what did I use for the diagram? Yeah, this is called mono draw. I did use NeoVim for a while. Yes, absolutely. I'm currently using Helix. Yeah, let's see. I think it's a Mac only thing. It's this year. It's funny. I think I'm building something similar, but from the other end. I'm solving the data persistence problem first. Yep, this is absolutely true. Why do you want to, publish everything when you don't need it? Do I happen to have a recommended config for Rust for, or maybe somebody else does for what? NeoVim? Yep. Wait. Windows has 14 gigabyte server Docker images? You're kidding. I did not even know that existed. Oh, that's cool. You're building a game like retirement planning suite. You want to build it in Rust and compile it to WASM. That sounds pretty cool. Yeah, it's funny. I think I'm basically building something similar to this here, but I'm going to have the WASM piece land last. Right? Because app storage is a current pain in the butt with WASM. And I think by the time I get there, WASM will have support for it. So what are the next WASM extensions? I don't remember what they're called. Feature extensions. Whoa, bright much? Oh, this is for Chrome. Oh, I want these over here. I don't want actual extensions. I want the WebAssembly. What do they call it? WASI? Yeah, and so WASI, I heard the same thing that it was getting a bit stuck. But some of the runtime implementers are just plowing forward regardless. WASIX? Yeah. Networking, multi-threading, asynchronous runtime. See this here. It doesn't actually support enough though. Oh, supports the POSIX file system API? Does it support... Ooh, that one's interesting. Okay. Base images are like 46 gigs. Once you install VC build tools and Rust and some other stuff, our builder image is now 14 gigs. Wow. And our DevOps say that the image is too big and they will, and like, okay, but we re-download everything each run anyway. Well, yeah, yeah. Okay, get it. File system support is interesting because if it's full POSIX, then you can run um, sqlite, but you can't now because full POSIX has basically um, memory mapped bits with um, locking, and that's what SQLite uses for signaling between processes using the same database. It's interesting though. All the apps you love. Curl, curl, curl. I see 3 curls on screen at the moment. I see a fourth. Hmm. There don't seem to be all that many apps that I love on there. Yeah, my pleasure. And welcome. Oh, Limsel, thank you for the follow. Oh yeah, I coming up in the next 5 minutes here. I have to end my stream, get ready for my day. I actually stream before work, so occasionally I'll watch a toggle bit as I'm getting ready to stream. Is what it is. Let's see where were we going? back to the code. I was mulling over this, right? How do we stream this? Because now it's not one thing. It's this, but it's, oh, wait, that's not it. That's not even correct. That should be repeated. It's a repeated page. Is it? How do we say something's repeated? Repeated. And the numbers are wrong. I want to swap that. I want the repeated thing at the end. There we go. 1, 2, 4. Let's make that 3. So at the end of this transaction, the DB checksum will be blah. Inside of this, we have this many pages. Okay. And each page has a page number, checksum, and data. Like it. Okay. Leptos. Yeah, what is Leptos? Is that a UI framework? Okay, I think because of this, I'm going to have to change a number of things. Yeah. We can no longer convert from a single database page to that. That just goes away. Boom. Really? There must... No, there's more broken than that. Come on. But did something panic up here? Oh, my proto file is broken. Can't compile. Protoc failed. Line 92. Database page. Okay. Missing field number. It looks like it's there. Do I have repeated in the wrong place? Space between repeated and page. Is that what it was? No, it did have one. Let's see. Okay, it looks like that took. Yeah. Now everything else is broken. Yeah, database page does not have that. It's now database transaction is returned from this. It's a stream of database transactions. That makes much more sense. All right. There we go. Now this here would then become a transaction. We would have these pages all together. We would create a gRPC message, serialize it to some vector. Okay, I like it. Well, good evening. How are you, Lumicode? All right, well, I have to run to work, so let's get a raid going. Yeah, I'm doing well. Doing well. I'm glad it's Friday. Looking forward to playing with some CNC stuff this weekend. I was going to try to CNC some shapes out of cedar. We'll see how that goes. Maybe some redwood. How are ya? And I don't know who to raid today. I took a peek. Um, Say same category. I do have to run. Um, let's make a quick decision. We're gonna raid Adam. All right. Hi, and welcome, Clear Mio. Oh, there's an echo. So, till next time, y'all. Bye bye.